Hello, so today we're going to talk about speed and velocity. So this is Unit 4, Lesson 4. So our objectives for this unit is to define speed as distance an object has traveled divided by time, solve problems about speed, define velocity as the speed of an object in a certain direction, and interpret information about speed and velocity presented in tables and graphs. So speed is the distance traveled divided by the time interval during which the motion occurred. So normally, objects do not travel at a constant speed. So the average speed would be the total distance divided by the total time. So an example, we're going to find the speed. So if Jay walked 4 miles in 2 hours, we know our equation is going to be speed equals distance over time. So we're going to have substitute 4 miles in for distance, 2 hours in for the time. So we get that his speed was 2 miles per hour. So if we look at velocity, however, this is the speed of an object in a specific direction. So we always have direction when we are talking about velocity. So imagine 2 birds leaving the tree at the same time. They both fly at 10 kilometers per hour for 5 minutes. Why don't they end up in the same place? So velocity appears to be very similar to speed. However, when describing the velocity of an object, you need to provide a magnitude and a direction. So magnitude is the speed of the object, and the direction, of course, is the direction the object is moving. So velocity equals displacement over change in time. So our equation is going to look like V equals delta x, so that's displacement, over delta t, so that'd be the difference in time. So if Sarah goes for a hike on a trail that is 5 kilometers long, she starts at 3 p.m. and finishes at 5 p.m. The end of the trail is 300 meters south of the beginning of the trail. What is Sarah's average velocity? So we need to find her total displacement, which in this case, if she starts at 0 and ends at the 300 meters, then her displacement is 300 meters south. And the change in time, well, she started at 3 p.m. and she finishes at 5 p.m. That's a difference of 2 hours, so delta t is going to equal 2. So then you just have to do the 300 divided by 2, so that gives us 150. So her velocity is 150 meters per hour south. So we can write that as Sarah's average velocity was only 150 meters per hour south because her final position was just 300 meters south of her starting position. So calculating speed and velocity. So if Kevin swims 100 meters to one end of the pool in 20 seconds and he swims back in 25 seconds. So we want to find out his average speed for the first leg of the race. So if he does 100 meters in 20 seconds, that means he's traveling 5 meters per second. But what is his velocity over the first leg? So you take that positive 100 meters because he's going in one direction, divided by 20 seconds, so he has a positive 5 meters per second. So if you notice, we actually put that positive sign in there because that shows that he's moving in a forward direction. So, okay, our next question here. So we want to know his average speed for the entire swim. So you take 200 meters, because that's 100 meters down and 100 meters back, divided by 45 seconds, because that's 20 seconds, plus the 25 seconds. So when you divide the 200 meters by the 45 seconds, you get 4.44 meters per second. But now what his average velocity for the entire swim would be, it's actually going to be 0 because his displacement is 0. Because remember, if you go positive 100 meters down, you're also going negative 100 meters back. And if you have 100 meters minus 100 meters, it's going to give you 0. So 0 divided by anything is going to give you 0. Alright, so in this case we have our table here. So it's position of the ball from pitcher to catcher's glove and time after leaving the pitcher's hand. So as you notice here, as the ball moves from the pitcher's hand to the catcher's glove, it's increasing meters because it's getting farther and farther away. And over here, also time is going to be increasing. So we want to know the average speed of the ball from the time it left the pitcher's hand to the time it was 10.8 meters from the pitcher's hand. So we're looking right here, this 10.8. So the average speed is going to be the distance over time. So in this case, you have 10.8 meters, which is right here. Go over, get your time, which is 0.48 seconds. Run the math, and you get 22.5 meters per second. So if we want to know the average velocity of the baseball between this time the ball was pitched and the time that it hit the catcher's glove at about 18 meters. So now we're going to be looking at the full length because we want the end point. So average velocity is equal to 18.4, which is about 18 meters. And the time is 0.96 seconds. So run the math, and it's going to equal that 9.2 meters per second towards the glove. So if you notice, we had to put in that towards the glove because we have to have that direction because we're talking about velocity. So if you were asked to determine an object's speed, what information must you have? Must you have the distance and period of time, distance and change of position, period of time and direction, or distance and direction? And here, you remember you need to know your distance, and of course you always need time. So if you look in here and it doesn't say anything about time, you know you can get rid of those. So both B and D you can get rid of. But then you look at distance or direction. Well, direction is what we need for velocity. In this case we want speed, so we know A is going to be our answer. So it takes a car 1.75 hours to go from mile marker 10 to mile marker 115. What is the average speed of the car? So remember, you need to find your total distance. So if you go 115 minus 10, that gives you 105. So we have speed, we have 105 miles. We need to know the time. In this case, we're given that it's 1.75 hours. So you can run your math, and you get your answer as being B, 60 miles per hour. So a bicyclist is in a 50-kilometer race. The cyclist says that they have an average velocity of 35. What is missing in the cyclist's velocity? So all they're saying is that they have a velocity of 35. But so what else are they missing? Well, first you can say, okay, it's 35 what? So we have to have some sort of units. So any of these that don't say units, we can get rid of. So we can get rid of C. But remember, we're talking about velocity. So anytime you have velocity, you also need direction. So we know we have to have two parts, so we get rid of A. And if you look, B says distance, but distance is going to be part of that 35. And we already know that it's a 50-kilometer race, so that's not missing. So the only thing missing here is the units and the direction. Okay, so use the following table of a school bus during morning pickups to calculate its average speed between 2.8 kilometers and 4.2 kilometers. So here's our distances. These are the times. So we can label this as distance 1. This would be distance 2. This would be time 1. And this would be time 2. So you start off by taking your distance 2, subtracting it from your distance 1. So we have our total distance between the 2 points that we're looking at. In time, you take time 2, minus it from time 1, and that gives us a total time frame that we're looking at. So that's going to give us 1.4 kilometers divided by 0.033 seconds. So when we calculate that out, that's going to give us 42.42 kilometers per second. And when we round that, it's going to give us that 42 kilometers per hour. Okay, so the following is a graph showing the displacement and times for a winner of a horse race. What was the average speed of the horse that won the race? So we were looking for average speed. So if you look here, nice even one, we can do 15 seconds, 300 meters. So you go 300 divided by 15. And that's going to give you your 20 meters per second. So that's going to be B. So what I did here is I went at our end time, which is 15 seconds, came up here and saw where the line crossed at, and went over and grabbed that 300. Okay, so remember that Wednesday the 10th, I'll be traveling up to Manistee, so I will not be in the office, and I will be sending out a recording for that. And the same for Wednesday the 17th and Thursday the 18th. I have meetings that I have to be in, and therefore I will send out those recordings. Remember that winter break starts on the 20th, and classes resume on Monday the 5th. So remember, homeroom's at 10 a.m. And make sure that you use your break wisely. And if you do have lessons that you need to make up, make sure that you do so. All right, if you have any other questions about speed and philosophy, please let me know. Thank you.